In this lesson, we are still solving systems. So once again, that's when you have two or more equations with the same variables. And today we are going to solve them with a method called elimination. So you have learned graphing so far. Wherever the two lines intersect, that's their solution. If they're parallel and they don't intersect, that's no solution. And if they're coinciding lines or on top of each other, that's infinitely many solutions. And the last lesson you learned was substitution, and that's where we did bread meet bread. And this method is called elimination. So it's hard to say which method you're going to like the best from year to year. Some students like substitution better, and other times some students like elimination better. So it's just hard to say. So they're different methods completely from one another. Now, for example, if I wanted to solve this problem by substitution, it'd be messy because none of these variables have a 1 in front. So the equation would give me fractions when I tried to solve for one of the variables, and I'd have to solve using substitution with lots of fractions, and that'd be a mess. You know, if I wanted to graph these, I'd have to solve them both for y. So sometimes elimination is easier if the numbers in front of the x's and the y's aren't ones at all. So what you're looking for with elimination, you want same number, different sign, either in front of the x's, or you want same number, different signs in front of the y's. That's elimination's goal. Same number, different signs in front of the x's, or same number, different signs in front of the y's. If you have that, you're ready to rock and roll. So looking at this one, I've got it. In front of the y, I've got a -6 and a +6. So as long as I have same number, opposite signs, we're ready to go. We would put an addition sign, and we would add, and go from there. This one, these are not same number, opposite signs. Neither are these. So we'd have to make these be the same with opposite signs. Or we would have to make the y's be the same with opposite signs. And I'll show you how to do that as we go down below. All right, number 1. Let's see if it is elimination ready. So you're looking for same number, opposite signs, either in front of the x or in front of the y. Do you have it? You do. There's a -1 in front of the y and a +1 in front of the y of the bottom equation. This is elimination ready. -1, +1. So you put your plus sign and you add. So remember, there's 1's in front of these that you don't see. So 1x plus 1x makes 2x. -y plus y makes 0. Shoop, eliminated. And 7 plus 15 makes 22. And then you divide both sides by 2. And you get 11. Now remember, you can't stop until you have a variable, both variables, the x and the y. Okay, at this point, you pick the equation you like the looks of best. And it's up to you. Some people might pick the top equation and some people might pick the bottom. I'm going to pick this bottom equation. So I'm going to rewrite my bottom equation. I just like the looks of it the best because it didn't have a subtraction sign, quite honestly. And we're going to substitute in what we just found. Since this is what x equals, we're going to take this 11 and plug it in the x. So I put 11 into the x, recopy plus y equals 15. And then to get y by itself, I get rid of this +11 by subtracting it. And then 11 minus 11 makes 0. Shoop, bring down your y, bring down your equals. And 15 minus 11 makes 4. How do you think we'd write it as an ordered pair? 11, 4. Remember, you want to write it alphabetical, and x comes before y. And this is elimination. So if the problem is already ready for elimination, same number, opposite signs in front of one of the variables, the problem's not that bad. If it's not elimination ready, then, you have more work to do. And we will see one of those in a little bit. Okay, moving on. let's look at number 2. All right, does it look like it's elimination ready? Yes, I have the same number with opposite signs in front of the x's. So this is elimination ready. So I put my plus sign and I add. So 2x plus negative 2x is 0. Shoop, eliminated. 3y plus 9y is 12y. Bring your equals down. And 11 plus 1 makes 12. And then to get y by itself, I undo this multiplication with division. So I divide both sides by 12. And y equals 1. 12 divided by 12 makes 1. Okay, at this point, I decide which equation I like the looks of best. Do I like the top equation better or the bottom? I like the looks of the top equation better, me personally. But it doesn't matter. I can work with the bottom one as well. So I'm just going to recopy that top equation since I like the looks of it. Now I'm going to substitute in. Now this time we found what y equals. So if this is what y equals, I'm going to take this 1 and I'm going to put it in the y. So I recopy 2x plus 3, slap parentheses down, plug your 1 into your y, and recopy the equals 11. Now we're going to work on solving this equation. So 3 times 1 makes 3. So I've got 2x plus 3 equals 11. And now to get x by itself, I'm going to get rid of the addition of 3 by subtracting it. 3 minus 3 is 0. Shoop. Drop down your 2x. Drop down your equals. 11 minus 3 makes 8. And your last step, what would you do? You would divide by 2. To undo multiplication, you divide. So we divide both sides by 2, and 8 divided by 2 makes 4. Okay. As an ordered pair, how would you write it? 4, 1. You want to write it alphabetically, and x comes before y. And that's the solution using this method called elimination. So these last 2 problems were elimination ready. We had same number, different signs in front of the x's on this one, and we had same number, different signs in front of the y's on this one. So as long as they're elimination ready, you put your addition sign and add. All right, look at 3. Is this elimination ready? Nope. The m's do not have same number opposite signs, and the n's do not have same number opposite signs. So we have to make it elimination ready. Either we will turn the m's into the same number, or we will turn the n's into the same number. It's our choice. Okay, I'm going to turn the n's into the same number. So right now there's a 6 and a 3. So what you have to ask yourself is what's the smallest thing a 6 can divide into and a 3 can divide into? So think of their multiples. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18, etc. These are numbers that 6 can divide into. Think of your multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, etc. These are the numbers that 3 can go into. So look to see what's the smallest number they both have in common in their list. And they both can go into 6. Now they can also both go into 12, but I want to pick the smallest just so I can work with smaller numbers. So since they both can go into 6, I'm going to turn these both into a 6. But one needs to be positive and one needs to be negative. So do you see how the top equation's already a positive 6? So we're going to leave this equation alone. So let me just rewrite the top equation because I'm not going to do anything to it because it's already a positive 6. Now we need to turn the bottom equation into a negative 6. Okay, so we have to ask ourselves, what do we have to multiply by to make it a negative 6? So right now it's a negative 3. So negative 3 times what would make a negative 6? a positive 2. And then you have to remember to multiply all 3 things. So let me multiply. 2 times 5m is 10m. 2 times negative 3n is negative 6n. And 2 times negative 16 is negative 32. So now let's look. Do I have the goal I wanted to have happen? Yeah, we have a positive 6 and a negative 6 in front of the n. So they need to be same number, different signs. Okay, so now that it's ready, I put my addition sign and I add. So here we go. Remember there's a negative 1 here. So negative 1m plus 10m makes 9m. 6n plus a negative 6n makes 0. Shoop, eliminated. And 14 plus negative 32 makes a negative 18. And then to get m by itself, what would you do? You would divide by 9. And negative 18 divided by 9 makes negative 2. Okay, so now I need to find the equation I like the looks of the best. So, is it the top equation? Is it this bottom equation? Or is it the new one that you created? Which equation do you like the looks of the best? I'm probably just going to recopy the top equation. So let me bring it down. And now let's substitute in. So we found that m is negative 2. So take this negative 2 and plug it into m. So negative, slap your parentheses down, put your negative 2 in there, recopy the plus 6 in, and the equals 14. Okay, so cleaning it up. A negative times a negative makes a positive, so that's a positive 2. Recopy. Drop your plus 6 in, drop your equals 14. Okay, so now we're going to solve for n. So looking on the side with the n, we need to get rid of that 2. So since it's a positive 2, we're going to subtract it. 2 minus 2 is 0, so that's gone. Shoop. Drop your 6 in down, drop your equals down, and 14 minus 2 makes 12. So what's your last step here? Divide by 6, and what do you get if you divide by 6? 2. Okay, so now I want to write this as an ordered pair. Think of your alphabet, A, B, C, D, E, F, G. And m comes before n, so it's negative 2, comma, positive 2, because m comes before n. Okay, this one was a little bit harder because it wasn't elimination ready, so we need to look at a few more like that. Okay, looking at number 4. Does it look like it's elimination ready to you? Nope. Your x's are not the same number with opposite signs, and your y's are not the same number with opposite signs. So I have to make it elimination ready. Either you're going to turn the x's into the same number, or you're going to turn the y's into the same number. And it doesn't matter which one you do. So last problem, I made the n's the same. So this time, let's make the x's the same. So right now I've got a 3 and a 4. Okay, so this is what you have to do. You have to figure out the smallest number that 3 can divide into and that 4 can divide into. And some of you will just know this, and some of you will not. So think of your multiples of 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, etc. These are things that 3 can go into. Now think of your multiples of 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4, etc. These are things that 4 can divide into. So what's the smallest number they both have in their list? They both have the 12 in their list. That means they can both go into 12. Okay, so we are going to turn these into 12s. So remember, one needs to be a positive 12 and one needs to be a negative 12. And it doesn't matter which one's the positive and which one's the negative. So I may do it differently than you. It's okay. Let's just make the top one the positive 12. So right now, it's a 3. What would you have to multiply 3 with to get a positive 12? 4. Okay, so we're going to multiply the top equation by 4. Now, a lot of students will think that because you're turning them into 12s, you'll multiply this by 12. But if you multiplied this by 12, 12 times 3, you'd get a 36. And that's not doing what you want. And if you multiplied this by 12, 12 times 4 is 48. They're still not same number, opposite signs. So you have to pay attention to what it already is and what would you have to do to make it a 12. Okay, so now that's going to be the positive 12. Now let's make the bottom one the negative 12. So right now it's a 4. What would you have to multiply 4 with to get a negative 12? A negative 3. Okay, here we go. And we need to multiply all 3 things. We need to multiply all 3 things. So here we go. 4 times 3x is 12x. 4 times 2y is 8y. And 4 times 7 is 28. In the bottom, negative 3 times 4x is negative 12x. Negative 3 times negative 3y is a positive 9y. And negative 3 times negative 36 makes a positive 108. Now look, is it elimination ready? Yes, the x's have same number, opposite signs. So we did what we were supposed to do. Yay, us! Put your addition sign and add, add, add. So if you add 12x plus negative 12x, you get 0. Shoop! Eliminated. That's why this is called elimination, yo. 8y plus 9y is 17y. Bring down your equals. And 28 plus 108 is 136. Okay, and then do you know what I would do to get y by itself at this point? I would divide by 17. So I need to take 136 and divide by 17. So I'm undoing my multiplication with division. And if you divide 136 by 17, that makes 8. All right, so now I need to pick the equation I like the looks of the best. So I have many to pick from. So I could use, I dropped my marker. I could use this first equation, the second equation, or either of my new ones. I think I like the looks of the top equation the best. Okay, so I'm going to take this top equation and just rewrite it. 3x plus 2y equals 7. Okay, now we're ready to substitute in. So I know what y equals, so I'm going to take what y equals and I'm going to plug it in the y. So recopy 3x, recopy plus 2. As soon as you see your y, slap your parentheses down, plug your 8 into it, and recopy equals 7. Okay, at this point, we're just going to clean it up. So 2 times 8 is 16. So I've got 3x plus 16, and then bring down your equals 7. So now to solve for x, what do you think you do? You would get rid of addition of 16 by subtracting it. So 16 minus 16 is 0. Shoop. Bring down your 3x. Bring down your equals. And then 7 minus 16 makes a negative 9. And your last step, divide by 3. What do you get if you divide by 3? Negative 3. Okay, so now I need to write my answer as an ordered pair. What do you think it would be? Negative 3, 8. X comes before y. So negative 3, comma 8. How you feeling? Okay, let's keep just working some examples. That's how you get good. You just need to practice. All right. So let's look at 5. Is number 5 elimination ready? Nope. The x's are not same number, opposite signs. The y's are not same number, opposite signs. So far, I've picked the ones that we're going to make the same. If I didn't tell you, you'd have to just do whatever you wanted to do. So if I wanted to make the x's the same, I'd have to figure out the smallest number 4 and 7 can go into. And I know it's 28. So I can make these 28s if I want. Or I ask myself, what's the smallest thing 2 and 3 can go into? And that's a 6. So I could turn these into 6s if I want. So you just need to pick. Do you want to make these x's 28s or do you want to make the y's 6s? I'd rather make the y's 6s because they're smaller numbers. But some people would rather make the x's 28s because they'd rather just fix the first number. It's up to you. I'm going to fix the y's. Okay, so the smallest number 2 and 3 divide into is 6. We already talked about that. No, I guess we didn't talk about that one. So let me just show you. 2 and 3. Think about the things that they go into. Think of your multiples. 2 times 1, 2 times 2, 2 times 3, 2 times 4. These are numbers that 2 can divide into evenly. Think of your multiples of 3. 3 times 1, 3 times 2, 3 times 3. So you can see the smallest number that they can both go into is 6. So I'm going to make them 6s. Now remember, you want one to be a positive 6 and you want one to be a negative 6. And it doesn't matter which one is which. Okay? I'm going to make the top one a positive 6 because it's already positive. All right, so it's already a 2. What would you have to multiply 2 with to make a positive 6? A positive 3. So we have to multiply the top equation by 3. Okay, so that'd be the positive 6. Now we need a negative 6. So right now, it's a negative 3. What would you have to multiply negative 3 with to get a negative 6? A positive 2. Okay. Once you decide that, this is when you multiply all 3 things. You've got to multiply all 3 things. So let's do it to it. 3 times 4x makes 12x. 3 times 2y makes 6y. And 3 times 14 makes 42. And a lot of times students will forget to multiply their number with the guy behind the right side of the equals. So be very careful. Remember to multiply all 3 things. Okay, bottom equation. 2 times 7x makes 14x. 2 times negative 3y makes a negative 6y. And 2 times negative 8 makes a negative 16. So now look, is it elimination ready? Yes, it is. The y's have same number, opposite signs. So we did what we were supposed to do. Yay, us. Okay, so put your plus sign and add, add, add. So 12x plus 14x is 26x. 6y plus negative 6y is 0. Shoop, eliminated. And 42 plus negative 16 is 26. Now what? Divide by 26. And you get x equals 1. All right, now you get to pick the equation you like the looks of the best. Do you like your first equation, your second equation, or either of these new guys? I think I like the first one. All right, so this first equation, I'm just going to bring it down. 4x plus 2y equals 14. Okay, now it's time to substitute in. I solve for x, so since x equals 1, I'm going to take this 1 and I'm going to plug it in the x. So 4, slap your parentheses down, get your 1 in there, recopy plus 2y, recopy equals 14. Okay, now we just need to clean it up and solve. So 4 times 1 is 4, recopy. So now to get y by itself, what do you think? This is a positive 4, so we're going to subtract it. We're trying to 0 that away, and 4 minus 4 is 0. Shoop, it's out of there. Bring down that 2y, bring down that equals. 14 minus 4 makes 10. And your last step, divide by 2. And if you divide by 2, you get y equals 5. All right, what would it look like as an ordered pair? 1, 5. And that's the solution to our system. Is it getting easier? Are you starting to understand? Okay, now I need to show you one that works a little bit differently, but we started the same. Let's look at number 6. Is it elimination ready? No. Those are not same numbers, opposite signs. Those are not same number, opposite signs. Do we want to make the x's the same, or do we want to make the y's the same? It's up to you, quite honestly. So right now, there's a 1 right here. Let's just do the y's. So we're looking at a 3 and a 1. So what's the smallest thing a 3 and a 1 can both divide into? Do you guys know? It's 3. 1 times 1, 1 times 2, 1 times 3, 1 times 4. These are all things 1 can divide into. 3 times 1, 3 times 2, 3 times 3. So you can see the smallest number they both go into is 3. So 1 needs to be a positive 3 and 1 needs to be a negative 3. Okay, do you see how the top one's already a positive 3? So just recopy this equation. We're not going to do a thing to it because it's already got the positive 3 like we wanted. Okay, so the positive 3 is taken care of. Now we need the negative 3. So right now it's a 1. What do we need to multiply 1 with to get a negative 3? Negative 3. And don't forget to multiply all 3 things. So negative 3 times 5x makes negative 15x. Negative 3 times 1y makes a negative 3y. And negative 3 times positive 3 makes a negative 9. Okay. So are the y's ready now? Yeah, same number, opposite signs. So put your addition sign and add. 15x plus negative 15x is 0. Shoop. 3y plus negative 3y is 0. Shoop. So if there's nothing left on the left side but 0, go ahead and write the 0. And 9 plus negative 9 is 0. Shoop. So if there's nothing left to write, you got to write the 0. Okay, so sometimes variables disappear. So when variables disappear, you either have a true statement or a false statement. Does 0 equal 0? Yes, this is true. So you can either write all real numbers or infinitely many. I would take either thing. All real numbers or infinitely many. That means if you were to graph these two lines, they would be coinciding. They'd be on top of each other, touching everywhere. So that's why there's infinitely many solutions. And so if these would have zeroed out and these would have zeroed out, leaving 0, but this side would have made something different, like 8. Let's say it said 0 equals 8. Then that would be false and you would write no solution. Okay? So if it's a true statement, infinitely many, but if it's a false statement, so I'm just going to write a false statement. So if you get like 0 equals 8, that's a false statement, then you would write no solution. Or you can remember the symbol for no solution, which is a 0 with the slash through it. Okay, so I'm not going to go ahead and do 7 just to save us some time. So we're going to stop right there, and hopefully you're understanding. Smiley face.